Cardline software has been created by CardGio Corporation. It consists of two services. First is the processing and interpretation of the MIT and MTT data. Second is the visualization of any kind of wireline data. Our company can also process the MIT data for pipe deformation analysis, known as PDA. In this video, we describe how to work with the processing and interpretation of the MTT data. First, we should convert the LAS data into the binary CGF file. Our method of processing MTT is based on the formula which stresses that the wall thickness is proportional to the measured MTT phase. We use statistical method for calculating wall thickness and do not require calibration runs. Statistical calculations are applied for every joint separately, because two joints with the same casing size could have different metal permeability. The shading zones near collars are also processed. Now let's run the MIT processing. First, fix all collar positions. Then run MTT processing. Now we fill the spreadsheet for all the zones with the different casing sizes. Let's first process the MTT zone by zone. This means that the same proportionality coefficient between measured phase and the wall thickness is used for the whole zone. The last track shows minimum, maximum, and the average MTT wall thickness curves. The blue curve is the MTT thickness loss, scaled from 0 to 50%. Every track division is equal to 10%. The previous track contains all 12 MTT wall thickness curves and an image. The image is scaled from big to small, where the red color means wall loss. We can demonstrate to you that the different joints have different metal permeability. Have a look at joint 12 and 13. When we drag press left mouth, the line in the cross-section pit percentage shows that both joints have approximately the same corrosion pit, that of 16 to 20%. At the same time, the calculated wall thickness is different. This happens because of a different metal permeability for joints 12 and 13. Let's recalculate the MTT using a joint-by-joint method. As you can see, now joints 12 and 13 show the same correct wall thickness. Consider the cross-section. The brown line is MIT plus MTT and is now equal to OD, which means that the wall thickness has been calculated correctly. We have the ability to see a pure MTT data or MIT plus MTT data. Now, recall the Express Joint Summary window. Express Joint Summary allows you to sort all joints by MTT and jump to the worst joint. In this case, it is a joint number 9. It has 2 holes and essential wall thickness loss. Drag the mouse over it. What we see is the cross-section window and the fact that the MIT and MTT sensors do not align. Here is the MIT pit. Here is the MTT PID, and here's the first MTT sensor. Let's then align MIT and MTT. As you can see, cross-section looks much better now. Then switch the mode to show MIT plus MTT for the brown curve. The combined MIT-MTT joint summary is created and saved in a data directory. Depending on which of the MIT or MTT corrosion pits is bigger, you can determine if the corrosion is internal or external. Now we will show you how to modify the MTT color palette to underline different MTT features. Click the right mouse on the MTT image and select Edit Color Palette. By moving the slides or changing the scale, we can show more or less of each of the MTT's features. After finishing the MTT processing, we should create a final PDF report, which contains images, tables, and a log view. Here is the created PDF report. This concludes our presentation on MTT. For more information, please visit us at our website at www.cardgio.com.